Good morning, students. In last class we discussed D block elements. Okay, D block elements. First we discussed electronic configuration of D block elements. Then variable oscillation states. Variable oscillation states. Okay. Now in this class we discuss magnetic properties. Magnetic properties. Okay. In D block elements is arranged in between S and P block elements. Okay. Whole periodic table, D block elements are arranged in between S and P block elements. Next, మనం electronic configuration అనేది చూసాం last class లో. Electronic configuration చూసినప్పుడు first I can take scandium. The atomic number of scandium is 21. Electronic configuration is argon. Okay, argon means 18. Then remaining 4s2 3d1. Okay, same way we can write 21 to 30 elements. Okay, electronic configuration of 21, the element 21 to 30. That means scandium to zinc. Okay, now magnetic properties. Magnetic properties means here, how many ampere electrons are present here? This is 2 completed. In D block elements, D orbital, only 1 ampere electron is present. 1 ampere electron is present. Okay, that means each, okay, in D block elements, each element can have unpaired electrons. ఓకే, ప్రతి దాంట్లో మనకి అన్పేర్డ్ ఎలక్ట్రాన్ అనేది ఉంటుంది. లాస్ట్ వన్ జింక్ లో దెర్ ఈస్ నో అన్పేర్డ్ ఎలక్ట్రాన్. ద అటామిక్ నెంబర్ ఆఫ్ జింక్ ఈస్ 30. ద ఎలక్ట్రానిక్ కాన్ఫిగరేషన్ ఈస్ ఆర్గాన్. ఓకే, 4s2 3d10. ఓకే, in s orbital 2 is filled, so this is complete orbital. Then in d orbital 10 electrons are present. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Except zinc, all elements in 3D series, okay, 3D series and 4D series and 5D series also. ప్రతి series లో మనకి లాస్ట్ గ్రూప్ ఎలిమెంట్స్ తప్ప, లాస్ట్ గ్రూప్ ఎలిమెంట్స్ ఏంటమ్మా? జింక్, కాడ్మియం, మెర్క్యూరీ. లాస్ట్ గ్రూప్ ఎలిమెంట్స్ తప్ప అన్ని ఎలిమెంట్స్ కూడా మనకి అన్పేర్డ్ ఎలక్ట్రాన్స్ ప్రెజెంట్ అయ్యి ఉంటాయి. ఓకే, ఓన్లీ లాస్ట్ గ్రూప్ ఎలిమెంట్స్ తప్ప అన్ని గ్రూప్స్ లో మనకి డి బ్లాక్ ఎలిమెంట్స్ లో అన్ని గ్రూప్స్ లో మనకి అన్పేర్డ్ ఎలక్ట్రాన్స్ అనేవి ప్రెజెంట్ అయ్యి ఉంటాయి. ఓకే, మ్యాగ్నెటిక్ ప్రాపర్టీస్ మీన్స్ ద మ్యాగ్నెటిక్ ప్రాపర్టీస్ ఇస్ డిపెండ్స్ అపాన్ ది నెంబర్ ఆఫ్ అన్పేర్డ్ ఎలక్ట్రాన్స్. నెంబర్ ఆఫ్ unpaired electrons. Okay, here next I can take titanium. The atomic number is 22. Electronic configuration is argon 18. Then 4s2 3d2. Here 2 unpaired electrons are present. Okay, that means each electron, here 2 unpaired electrons are present. Here only 1 unpaired electron is present. Each electron is regarded as a micromagnet. Okay, each electron is regarded as a micromagnet. మనకి యాక్ట్ చేస్తాయి. ఎప్పుడు ఏ కండిషన్స్ లో? based on magnetic properties. Okay, each electron is regarded as a micromagnet is based on the magnetic properties. What is micromagnet? Micromagnet means the electron can have charged particle, okay, and the electron can have own spins. Okay, this is positive of, this is minus of. Okay, this is plus of, this is minus of. That means each electron can have charged particle, okay, can have charge and it have own spin. Own spins means this is positive of, this is also positive of, this is minus of. Okay, Next, that means magnetic properties means magnetic properties is based on the number of unpaired electrons. Okay. Then each electron is regarded as a micromagnet is based upon the magnetic properties. These are classified into 3 types. How many types? 3 types. What are they? The first one is paramagnetic properties. The second one is diamagnetic properties. The third one is ferromagnetic properties. Okay, the magnetic properties are classified into 3 types. The first one is paramagnetic properties, diamagnetic properties, and the last one is ferromagnetic properties. What is para? What is dia? What is ferro? Okay, paramagnetic properties is defined as the number of unpaired electrons is present in the element or compound. Okay, this is based on the number of unpaired electrons. Okay, here I can take external magnetic field. Magnetic field can have 2 poles. One is north pole, another one is south pole. This is magnetic field. Okay, here I can take compound. Okay, any substance or compound. Okay, the substance is placed in external magnetic field. It is weakly attached to the external magnetic field. What is paramagnetic properties? We can apply the external magnetic field to the substance. Okay, then the substance weakly attached to the external magnetic field. External magnetic field is called paramagnetic properties. It's called paramagnetic properties. Okay, then these properties are called paramagnetism also. If we remove the external magnetic field, then the substance lost their magnetism. Okay, ఒకవేళ మనం దీన్ని రిమూవ్ చేస్తే ఇది వీక్లీ అటాచ్డ్. సో ఇది మనం రిమూవ్ చేస్తే మ్యాగ్నెటిక్ ఇది మనం రిమూవ్ చేస్తే మ్యాగ్నెటిజం కూడా లాస్ అవుతుంది. సబ్స్టెన్స్ అనేది దీనికి ఉన్న మ్యాగ్నెటిజం లాస్ అవుతుంది. దీన్ని మనం పారామాగ్నెటిక్ ప్రాపర్టీస్ అంటాం. ఇట్ ఈస్ బేస్డ్ ఆన్ ది నంబర్ ఆఫ్ అన్పేర్డ్ ఎలక్ట్రాన్స్ ప్రెసెంట్ ఇన్ ది ఎలిమెంట్ ఆర్ కాంపౌండ్. ఓకే, the paramagnetic properties are based on the number of unpaired electrons present in the compound. Examples are scandium plus 2. Scandium plus 2 means here scandium 21 atomic number. I can write electronic configuration argon 4s2 3d1. Here plus 2 means remove 2 electrons. Remove 2 electrons from S. Okay, then we have only one unpaired electron. Okay, paramagnetic means number of unpaired electron is present in the substance. Here only one unpaired electron is present. So we can write scandium plus 2. Okay, it is a paramagnetic substance. Next, titanium plus 2 also. Titanium plus 2 means titanium 22 4s argon 4s2 3d2. Okay, here totally 4 electrons are present in valency shell. Okay, 2 are in s orbital and 2 are in d orbital. Here titanium plus 2 means we can remove 2 electrons. We can remove these 2 electrons. Then we have two unpaired electrons in d orbital. So titanium plus 2 is the example of paramagnetic substance. Okay, next vanadium plus 2 also same way. Okay, scandium, titanium plus 2, vanadium plus 2, manganese plus 2 and so on. Manganese, chromium, iron, cobalt, nickel. Okay, and copper also. Okay, these are the paramagnetic substances. What is paramagnetic properties? Paramagnetic properties means the substance is placed in the external magnetic field. Okay, if we remove the external magnetic field, then the substance lost their magnetism. Then the substance lost their magnetism is called paramagnetic properties. Okay, the examples are scandium plus 2, these. Okay, next diamagnetic properties. Diamagnetic properties means when the substance is placed in external magnetic field, okay, this substance can repel, okay, can repel the external magnetic field. When the substance can place in external magnetic field, it repels the external magnetic field. Okay, then these particular substances are called diamagnetic substances, and these properties are called diamagnetism. Okay, if we can remove the external magnetic field, then there is no magnetism in substance. Then there is no magnetism. Okay, మనకి ఎక్స్టర్నల్ మ్యాగ్నెటిక్ ఫీల్డ్ సబ్స్టెన్స్ అనేది ప్లేస్ చేసినప్పుడు అది ఆ సబ్స్టెన్స్ ఎక్స్టర్నల్ మ్యాగ్నెటిక్ ఫీల్డ్ రిపల్ చేస్తుంది. ఓకే, ఒకవేళ మనం ఈ ఎక్స్టర్నల్ మ్యాగ్నెటిక్ ఫీల్డ్ రిమూవ్ చేస్తే ఆల్రెడీ వీక్గా అటాచ్ అయ్యింది కాబట్టి దేర్ ఈజ్ నో మ్యాగ్నెటిజం. మనం అప్లై చేస్తే రిపల్ చేస్తుంది, రిమూవ్ చేస్తే దేర్ ఈజ్ నో మ్యాగ్నెటిజం ఇన్ ది సబ్స్టెన్స్. దిస్ ఈజ్ కాల్డ్ డయామాగ్నెటిక్ సబ్స్టెన్స్ and these properties are called diamagnetism. Okay, examples are scandium plus 3, okay, titanium plus 4 and copper plus also. That means scandium plus 3 means scandium 21, argon 4s2 3d1. Here 3 electrons are present. 2 is from s orbital, 1 is from d orbital. We remove, then it gets argon configuration. Then there is no unpaired electrons here. Plus 3 means. So there is no unpaired electron. That is diamagnetic substance. Okay, unpaired electrons unte అది para, unpaired electrons అనేవి లేకపోతే that is diamagnetic substance. Next, ferromagnetic substance means when the substance is placed in the external magnetic field, okay, they attach strongly to the external magnetic field. Okay, if we can remove the external magnetic field, there is no loss of magnetism. ఒకవేళ మనం మ్యాగ్నెటిక్ ఫీల్డ్ ని రిమూవ్ చేస్తే magnetism అనేది దానికి అలాగే ఉంటుంది. సో magnetism is here in the substance. Okay, so magnetism is present in the substance. Why means here external magnetic field is applied to the substance. It is strongly attached to the external magnetic field. Strongly attached. If we can remove the external magnetic field, there is no loss of magnetism. It is called ferromagnetic substances. Okay, and the properties are called ferromagnetism. Examples are alloys of iron, cobalt, nickel. Okay, that is iron, cobalt, combination of two metals, 2 or more metals. Okay, next iron, nickel and nickel These are the examples of ferromagnetic properties. Okay, magnetic properties is based on the number of unpaired electrons. Okay, this can be divided into three types: paramagnetic properties, okay, diamagnetic and ferromagnetic. Para means the substance is weakly attached to the external magnetic field. Okay, if we lost the external magnetic field, this substance is lost their magnetism. It's called paramagnetic substances. Then examples are, if the substance if the substance have unpaired electron, then that particular substance is called paramagnetic substance. Examples are scandium plus 2, okay, titanium plus 2, only 2 electrons are removed. Here plus means loss, 2 means 2 electron loss. So scandium plus 2, titanium plus 2, vanadium plus 2, manganese plus 2, chromium plus 2, iron plus 2, cobalt plus 2, and nickel plus 2, and copper plus 2 are the examples of paramagnetic substances. And then diamagnetic substances. Substances means, here I can take substance, it is placed in external magnetic field. Okay, it repels that means the substance repels the external magnetic field. If we remove this external magnetic field, this substance has lost their magnetism. It is called paramagnetic substances. Examples are scandium plus 3. Scandium plus 3 means argon 4s2 3d1. Plus means loss. 3 means loss these 3 electrons. Then this scandium get argon configuration. That means no unpaired electrons. Okay, scandium plus 3 and titanium plus 3 and copper plus and so on. Okay, next. Diamagnetic substance అని ఎప్పుడు చెప్తాం? ఆ సబ్స్టెన్స్ కి unpaired electrons అనేవి లేకపోతే that particular substance is called diamagnetic substance. Ferromagnetic substance means when the substance is placed in external magnetic field, okay, then that substance is strongly attached to the external magnetic field. Okay, if we lost the external magnetic field, these substances can have some magnetism. Okay, is called ferromagnetic properties. Examples are alloys of the iron, cobalt, nickel. Iron, cobalt, iron, nickel, and nickel molybdenum. The total magnetic moment of the ion can be depends upon the number of unpaired electrons. The magnetic moment of the ion can be depends upon the number of unpaired electrons. The magnetic momentum is indicated with mu. It can be calculated from the formula mu is equal to square root of n into n plus 2. Okay, the magnetic momentum can be calculated from the formula mu is equal to square root of n into n plus 2. Here n is equal to number of unpaired electrons. Okay, if I can take n is equal to 1, that means the element can have only one unpaired electron. Here I can take scandium atom number 21, argon, okay, argon 4s2 3d1. Here how many electrons are present? Here scandium plus 2 means 2 electrons are released from S. Then we get argon 3d1 configuration. Here one unpaired electron is present. So I can take n is equal to 1, number of unpaired electrons is equal to 1. Then magnetic momentum mu is equal to square root of 1 into 1 plus 2. Then mu is equal to square root of 3. Root 3 value is 1.7 3 Bm. Bm means Bohr magnet. Okay, then I can take number of unpaired electrons n is equal to 2. Okay, then magnetic momentum mu is equal to 2 into 2 plus 2, 4, and mu is equal to 4 into 2 root 8. Root 8 means 2 point, okay, 2.83 Bohr magnet Bm. Okay, if n is equal to 3, then magnetic momentum mu is equal to square root of 3 into 3 plus 2. Then mu is equal to 3 plus 2 means 5. 5 into 3 root 15. Then that value is 3.87. Okay, Bohr magnet Bm. Then if n is equal to 4, then mu is equal to root 4 into 4 plus 2. That means mu is equal to 6 into 4, 24. Then 4 root 24 means root 25 means 5. That means root 24, 4 point something. Something means 89 Bm. Okay, then if n is equal to 5, then mu is equal to square root of 5 into 5 plus 2. Then mu is equal to 7 into 5, 35. Then 35 means root 36 means 6. So this is 5 point something. That means 91 Bm. Okay. If I can take n is equal to 6, n is equal to 6 means here iron is taken. Iron atomic number is 26. That means argon 4s2 3d6. Okay. Here Fe plus 2 means removal of 2 electrons. Removal of 2 electrons from S. That means argon, this is removed. Then 3d6. 3d6 means how many unpaired electrons is present in d orbital? 1, 2, 3, 4, 5. Okay, 6 means 1, 2, 3, 4, 5, 6. Okay, how many unpaired electrons is present in this element? 4 unpaired electrons are present. 1, 2, 3, 4. Okay, only 4 unpaired electrons are present in Fe plus 2 ion. This is paired, not unpaired. So only 4 unpaired electrons are present. 4 unpaired electrons means m is equal to 4. That means root 24. Okay, if m is equal to 7 means cobalt. Cobalt plus 2 ni ela తీసుకోవచ్చు argon 3d7. 3d7 means 2 orbitals paired, then remaining 3 unpaired electrons are present. How many electrons are present in 3d7? 3 unpaired electrons are present. n is equal to 3 అయితే మనకి mu is equal to 15. Then 3.87 is the magnetic momentum of the CO plus 2 cobalt plus 2 ion. Okay, if n is equal to 8 అయితే same process. 8 electrons are present here. Then only 2 unpaired electrons are present. 2 unpaired electrons means n is equal to 2. Then mu is equal to 2.83. If n is equal to 9, n is equal to 9 means here I can take copper. Cu plus 2. Cu means atomic number 29. Here first I can take Cu means atomic number 29. The electronic configuration is this one. Okay. Or we can write also 4s1 3d10 also. Okay. Then Cu plus 2 means remove 2 electrons. Remove plus means remove 2 electrons. Okay, remove 2 electrons from this valence shell. One is from S, then configuration is argon 3d9. Okay, Cu plus 3 కాబట్టి మనం 2 electrons remove చేసాం. Then 2 electrons remove చేస్తే the configuration is 3d9. 3d9 అంటే how many electrons are present? 1 2 3 4 5 6 7 8 9. Only one unpaired electron is present. So n is equal to 1. This is the Bohr magnetic momentum value. Sorry, magnetic momentum value. Okay. This is the calculation of magnetic momentum. Magnetic moment.